Greetings, programmers. So I'd like to talk a little bit more about collisions. And in this video, what I'd like to discuss is how we have a slightly more accurate collision. So I've actually started with a completed program this time, so you can see what we're going to be doing. What I have here are two circles. One I'm controlling with the mouse. This is my source circle. And then in the middle there, you see the target circle. And when the two intersect, you'll see that the target circle lights up green. And I can go around the edges, and if you remember in the point collision, if you play around with it, if you click right on the edge, like in this corner, where the center of the circle I'm controlling with the mouse would be, it would still register a hit. So we want something that's a little more accurate in this one. And to do this, we got to do a little bit of math to get the solution here. And so this is what we're going to create. So when the two circles intersect, that's when the target circle will turn green. So I want to show you how to do this. Now again, what I want to do is start with the code that we have from the end of our mouse handler video. And so here we have a program that draws a circle to the screen and has the mouse handling involved. So the first thing I want to do is I need to add in the two circles that I'm going to be using. Now remember, we're going to add them as rectangles because there are no circles in PyGame. I'm going to call the first one the source circle, and this one is going to be moving with the mouse. So I'm just going to start it at 0, 0, and make sure that you give it a width and a height. We're going to use that width and height later on, both to draw it and to determine the collision detection. In addition, we need the target circle. And this one I'm going to put closer to the middle of the screen, so I'm going to put it at about 200 by 200. And again, I'm going to give it the same width just for convenience. Okay. Now in order also to make this work, I want to add a few other things here. We do have the XY here, that's where we're going to store the mouse coordinates. But I also want a Boolean to determine whether or not we have a collision situation. So I'm going to call it colliding, and I'm going to set this to false at the beginning of the program. So we're going to say the two circles are not colliding when the program starts, which may or may not be true. We're going to handle that later on in the code, determine if we are colliding. The other thing I want to do is to add that green color so that when it does collide, we'll have the color available to draw the circle in that color. So remember, the color sequence is red, green, and blue. And I'm doing green at halftone, so 128, which is half of 256. That's going to give us a slightly darker green. If we did it at 255, it would be a very bright lime green, but I prefer darker greens, so I'm going with the darker green here. Okay, so we have that set up. So the first thing I want to do is make sure that they're drawing to the screen. And so I'm going to go down to where we have our draw circle. I'm going to change it from drawing the rectangle, and what I want it to draw is the source rectangle, and then we're going to add another one to draw the target rectangle. Okay, so I'm going to copy and paste that and change the second one to target. Now do note that we are setting the width here. Probably would be better to say this, so source.width and target.width. That way, if you change the values in your rectangles at the top, those values will change with that. So let's go ahead and make sure that those are drawing correctly, and they are. Awesome. So the next step, once we have those circles drawing correctly, is to get that source circle to move with the mouse. So find the event type for mouse motion, and what we're going to do is here where we're setting the event position, let's go ahead and add another line and say that the source's center will equal that x, y. Okay, so by doing that, what that allows us to do is now when you move the mouse, that circle will snap to the mouse. Pretty cool, huh? So the next step is to do our collision. So in order to facilitate doing this collision, what we're going to do is determine the distance between the two circles. More specifically, we want to know the distance between the centers of those circles. And when that distance is less than the radius of both the circles combined, that means that the circles are touching. So, in order to do this, we're going to do something a little different than what we've done in the past videos. I'm going to add a function here to do that work for us, and I'm going to call it distance. And for the distance, we're going to have a point A and a point B. Okay? And then from the point A, I want to extrapolate an x1 and a y1. So we're going to take that from the A, and x2, y2 will come from the B. Now we could write all of the functions here so that we don't have to do this. I'm doing this to make my code more readable and you understand where the values are coming from. Now, if you remember the point distance formula, basically what we have is we have a delta on the x, and that'll be x2 minus x1, and then our delta y, or dy, will equal y2 minus y1. And then what we want to return is the square root of the sum of the squares of those two values. So what we have is math.sqrt square root of dx squared plus dy squared. Okay? Now, since we're using a math function, we do need to go back up to the top to our import statement and make sure that we import the math library. Okay. So, we need to test this out, make sure that the function is working, and we'll just go ahead and do that right in our program with our collision detection. So what we want to do is come back to the mouse motion, and where it says source.center equals x comma y, after that line, we want to check to see if the two circles are colliding. So I'm going to say if the distance between source.center, comma, target.center is less than source.width plus target.width. Oh, actually it's only half of that, isn't it? So source.width divided by 2, and let's make that 2.0. Well, let's just do 2, plus target.width divided by 2. Okay, so if the distance is less than the half the width of the source plus half the width of the target, then we know we have a collision. So we're going to say colliding equals true. And remember, the T in true needs to be capitalized. All right, now we want to have a corollary here. We're going to say else colliding equals false. And what this will do is, if we just had the colliding equals true, once the two circles collide, it won't uncollide. So here we're checking to see if they're not colliding anymore and reset it to its initial value. So let's save and test this program. Okay, well, nothing's happening. That's because I forgot to change the color. So let's come down to where we're drawing things, and let's put another statement in here. So we want to say if colliding, what we want to do is we want to draw the target. So let's copy and paste that code. Okay, and we want to draw it in green. Okay, so save and test that. Okay, still nothing. Alright, let's try something. Let's change the width of the circle to 0, and what that'll do is that should fill it in. I think that will fix this. And there we go. Alright, except my collision is not, it's only when I'm halfway through. So let's see why that might be. So let's try this. Let's put parentheses around our addition there to make sure that addition happens completely before we do the comparison. And no. And I think I see what I did here. So when we're drawing the circle, we're drawing it at the width of the target and the source. So this is actually not divided by 2 because that's the radius. And we want to add the two radiuses together. So a little error on camera. Not hard to fix. It was easy to find the error. Alright, so now let's try it. And there we go. A perfect collision. Now it does require a little bit of math, and one of the things I'll tell you about this is because we are using the square root function, square root can be very slow on some computers. So if you're relying on this as your collision detection method, if you have a lot of objects on the screen that you're trying to check collisions for, it may significantly slow down your program and make it very difficult or not very fun to play your game. So there you have it. We have our collision detection, which is a little more perfect. It'll definitely handle the shape. Works really great for irregular shaped objects. So I want you to try this out. Try putting it in your programs and see if you can't make a fun game using this type of collision detection.